Welcome back to Solve with Danny, and today we're going to be looking at exponential functions, looking at growth, looking at decay, and hopefully hating the topic just a little less. Okay, so the generic form of an exponential function that you may see is y equals ab to the x, where a is your initial value, b is your either growth or decay, and then x is usually some form of time. In another video, we're going to go through some real life applications of this, but for now, we're going to look at tables, look at the graph, and see, is this a growth problem or a decay problem? Okay, so the first one, I'm putting these on function notation. So f of x and y, it's the same, okay? But f of x is the fancy function way, all right? So I'm going to plug this into our calculator, get the table, and then we're going to graph. All right, so we got our TI-84. So this one is 4 raised to the x power. So if I want to see the graph, you can click graph, kind of see what it is that we're going to be looking at here. So you can see like, it grows super quick. And when I hit second graph, that's when I'm going to get that table. Now the table on my worksheet, which I'll go back to in a second, does start at -3. So we're going to scooch this table up just a little bit. Okay, now you might notice you're like, okay, this one doesn't even have an A, B, and an X. That's because technically this is 1 times 4 to the x. Okay, so our table, just to transpose it from the calculator. So we got some really tiny numbers happening here. And then we're growing real. All right, so to graph this, I mean, it's so, it's like just touching, that x-axis, but it's not technically touching. So you kind of just do the best you can there. And then we have 0, 1. We have 1, 4. I don't even know if I can fit 216 into this. Nope, I cannot. So it's like somewhere all the way up here. So you want to start it with the tail, and then it grows super quick. And we are going to put arrows on either end. You just do the best you can. And a proper graph is always labeled. Always label it. Okay, so let's identify some pieces of information here. So if we're looking at that y equals ab to the x, your a value or your initial value, that's really your y-intercept, which is right here. So let's label that as your y-intercept. And then our growth factor, that's your b value. So it's growing by 4, and we can tell that it's growing because if I was to put my pencil like on this grid, it's increasing. It's going up. The farther I go to the right, the higher and higher those values get. So therefore, this is a growth problem. So we can label this as growth. All right. And then we're going to make some insinuations about b values in a little bit here. Okay, so let's graph another one. This one is 0.5 to the x. So again, that a value is technically 1, but let's plug this in our calculator. All right, so we're going to get out that old equation, clear it out, and we have 0.5 raised to the x. We can look at the graph just so we can see what we're looking at. And then I like to look right at that table. So let's put this table down on our paper. All right, so -3 is 8. And 4, 2, 1, 0.5, 0.25, 0.125. So we can see it's getting smaller and smaller and smaller. So we've got -3, 1, 2, 3, 4, 5, 6, 7, 8, -2, 4, -1, 2, 0, 1, half, and then it gets tinier and tinier and tinier, but it's never actually crossing that x-axis. When it gets really, 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 really close but doesn't actually cross, it's called an asymptote. Later course. And then, oh, that is a bad curve. Sometimes the curves, you know, they don't always come out perfect. That's why you want to have really clear dots. And then we're going to label this. Oop, not Y. Silly me. Ooh, did I label that other one correctly? Oh, I did. Good. Okay. All right, so let's look at this. So as X increases, Y is decreasing. So since that graph is going down, this is a exponential decay example. And I do like to label my Y intercept. Just a good habit to get into. Okay. Let's try one more. So we get a different kind of decimal here. F of x equals 1.25 to the x. So let's graph this. We're going to get out that other one. And we got 1.25 to the x. Can you make a prediction? Do you think it's going to be growth or decay? Ooh, it is growth, a slower growth than that first one. Maybe the curve will be easier to draw this time. So let's look at that table and we'll put this down on our paper. So -3 is 0.512. Then we have 0.64, 0.8, 0.1, 1.25, 1.5625, and then another crazy decimal, 1.9531. And I'm not rounding these. I want it to be exact. Now, of course, you get some gross repeating decimal, different story. But write it all out when in doubt, okay? All right, let's graph this. -3 is about a half. And then it's kind of more than a half, kind of more than a half. Then we get 0, 1. Again, not exact. This is a tidy grid. Work with me, people. Okay. When we get to 1, it's a little bit over 1. It's still a little bit over 1. It's almost 2. And it keeps going. Now, resist the urge to draw this like a line. It is a curve. It's not a great curve, but it is a curve. I guess if I wanted to go one more in my table, I have 4 and then 2.4414. Oops. Get that one in there too. Okay, not perfect, but it's good. It's good, but it is a curve. It is not a line. So do draw it as best as you can curvy and label it. Okay, and so as x is increasing, y or f of x is also increasing. So therefore, this is growth. And we have our y intercept right there. That's going to get really important once you start getting into quadratics. If you haven't already, you do a lot of labeling in quadratics land. All right, so let's look at those 3 problems that we did. And the 2 problems where it was growth, our B value was 1.25 and 4. And when it was decay, it was 0.5. So here's a rule of thumb you can write down, take note of, whatever makes your heart happy. Okay, so A is our initial value. Or when you're graphing, it's your y-intercept. Now, these were really simple exponential ones. We'll get into some more advanced ones at a later time, okay? And then your B value, that's either your growth or your decay. Now, just by looking at it, can we tell if it's growth or decay? Yes, we can. You can do it without even graphing, which is kind of nice. But you can always graph it to be sure. You're going to have this calculator your whole Regents exam. Don't panic, okay? So we know it's growth when our B value is greater than 1. So if you've got like 1.000001, that's still growth. If you've got 10, that's growth, right? It's going to be decay when it is between 0 and 1. I'll zoom in on that so it's a little easier to see. So it's not going to go into the negatives. And if it equals 1, that's not really, when you multiply by 1, nothing exciting happens, right? So it's going to be strictly between 0 and 1. So you got like 0.5 or 1/2, 3/4, 7/8, 1/10. Something like that is going to be decay, and it's growth when it's bigger than 1. All right, so I hope that's helpful, and we'll do some more advanced ones in some later videos. Don't forget to subscribe, and I hope you hate math just a little less today. Bye, everybody.